All right, so number one. Oh, number one from written exercises, right? Okay, so you do the square root of 63. All right, so let's talk about. We're gonna talk about square roots in general, right? So do you know what the square root of 49 is? Because it's what same number times what same number is 49. Correct. Let's talk about the square root of 8. All right, and well, 4 times 2 is 8. Almost. Okay, so um, here's how we're going to teach it. Well, does it have to do with prison escape? Did we talk about prison escapes? Yes, it's a bus. Okay, then it is the prison escape video. Why would I feel like this? But this is new for this year, so I don't get that. Okay, so oh maybe. All right, so you got your bus, right? Bus shows up at prison. Who's getting off at prison? New people that like got sent to the prison, right? So like they're getting out. Okay, and and these guys are like this, and they're just walking out, right? And then like, I'm pretty sure this is from my experience with prison. I'm pretty sure this is pretty accurate. You got you guys out here, and they're like whistling, and they're like, "Look at the fresh meat." And then these guys are like, and they're walking in. They're like, "Oh man, should not have spray painted that wall." And they're like, and they're going this way. I should not have cheated on that test. And so like, and then they're going like they're inside the gates, right? Well, if you have twins, all right. So like a twin, this is like the number two. This is the number two. These these guys are twins, right? So if there's so these two guys are twins, right? And fast forward like a few days, so they've had to actually time to think about their escape plan. All right, so escape plan. People have tried to escape from prison, by the way. What usually happens is you get shot by the guards because they just basically have one move. I'm pretty sure this is pretty accurate. And the move is you have a tower. Guy needs a little cover and wait, what am I drawing here? Tower and right. Hmm? I'm gonna draw the guy up here. Okay, with 3 legs. No, he's. Ugh. Okay, hold on. All right, he's right there. That's a big gun or hand, and then you have, prison, right, building right here, and we can see behind the scenes because we have X-ray vision that they always try to make a run for it. Like, well, and usually they just get shot. So, so the twins though, they're like, all right, we got an idea. Listen, brother, we're both in here for life, and that's just not cool. So one of us is going to make a run for it, and the other one is going to get shot dead. But the good news is one of us will actually make it. So then they're like, oh, okay, let's go ahead and do that at noon. So then they both go out. They both go outside. A little suspicious that they're not at their normal bench press place. But they're over here, and so they're inside prison. See them? Inside prison. All right. All right, so they're inside prison. And they're like, all right, brother, on 3, make a run for it. Like, okay, 1, 2, 3, go. And so they both go. And This guy is running as fast as he can. Little does he know that night. I mean, I know they're brothers and all, but this serious business is your life. So one guy, like, I don't know what did he do. He messed with his brother's shoes so they could fall apart when he was running. And so you have one guy there, one guy there, running really, really fast. And the guard's confused. Oh no, I only have one bullet. Because that's how it works. They only have one bullet. And so the guard's like, all right, this guy. Boom, killed. Brother, no time to mourn. Goes, escapes, and this guy right here is out. Woohoo! And this guy's like, oh man, he got out. And he's like, see ya, sucker. And then he just walks away. Strolls. Oh, no, actually, a car pulls up. It's convertible. It's like a 1960 Cadillac. And so, it's a girl with like those glasses with those like oversized glasses with like white rims, white frame glasses. And he's like, hop over. She's like, scoot over. And then they swap seats because he drives because that's how it is. And then like, and there's fuzzy dice on the mirror. And then they go in perspective cam down far away. Okay. And that's it. Okay. So what happens is if you have a pair of numbers, one gets killed, the other goes out of the root. So if you want to take the square root of 8, for example, all right, so that's all your inmates in the bus. You got to line them up. So you line them up by making your factor tree. So they line up, and you're going to have 2 times 4, factor down to, you're going to factor them all the way down to prime numbers, so like 1s, 2s, 3s, 5s, 7s. So you can't chop them down anymore. You with me? So like 8, so like 2 times 4 is 8, and then 2 times 2 is 4, and I can't chop it down anymore. So you circle the pairs. Right there, you circle your pairs. One gets shot, the other gets out of the root, and the one that's behind there, even though he looks like one of the twins, you do not have your buddy. So that guy right there stays inside the root. Now if it's like, so it's 2 root 2. And so what's going on behind the scenes is the square root of 8 is the exact same thing as the square root of 4 times 2. Right? Because 4 times 2 is 8. Right? All right. And you could rewrite this. That's the same as the square root of 4 times the square root of 2. What is the square root of 4? That's how this happens right here. That's what's going on right here. So 2. So you had 2 of them. One got killed, one comes out. The square root of 4 is 2. The loner, this guy right here with no buddy, is left behind, ends up inside the root. 2 root 2. And you could always check your answer when you're doing square roots. It's always going to be this number times itself again times this number is original. You see? So if you want to check it, what do? So it's going to be what times what times what? 2 times 2 times 2, which is what? 8. And did we start off with 8? Then we did it right. So they're all checkable. You with me? Okay, so if we're going to do the square root of 63, number 1, the square root of 63 All right, so let's factor tree that bad boy. 9 and 7. Wait, why did my stylus just die on me? Hold on. There we go. 9 and 7. Now what? 3 and 3. Ah, fresh meat. Okay. All right. Now what? Mm-hmm. Well, I know. Let's go ahead and line them up in prison. So we're going to line them up in prison. We got a 3 times 3 times 7. All right. Line them up in prison. Okay, brother. Go. Go. Now we got our threes. We got our threes running for making a run for it. One gets killed. One's out of prison. The root is prison. So one is out of prison. The other's gone. 3 root 7. This guy's like, what about me? What about me? You're on your own, buddy. You're on your own because you did not sell me cigarettes. Okay, sorry. Because you have a swastika on your forehead. Okay, so yes, I have. Yes, I did. And the most disturbing scene, the most disturbing scene was the opening scene, in my opinion. That's when that's when I think I showed this to you actually. That's when yes. Yes, but he's like rumor has it like you're like harboring Jews or something. He's like no. And he's like, listen, you tell me where they are right now or I'm going to start killing your family. And so he had to gesture where they were and like one girl survived. Yeah, and like that scene is just like extremely disturbing to me. Um, most graphic scenes when they're shooting Hitler, because they just kept shooting him and not stopping, like they just pulverized him. All right, let's do more. Let's do harder ones. Okay, so number 3. All right, so 98. So look, there are other ways to do roots, and you're gonna get better at roots later. But this is like a sure shot way. Yeah. Like as you get more comfortable, there's faster ways, but like this, like I still do them this way. No, this is it's the prison escape method that I think is the way to go. Okay, so you got to bust up and always put your little numbers like 100 for example. If you're gonna break up 100, sure you could do 10 times 10, and then you could do 2 and 5 and 2 and 5, but that's a mess. I don't like that because I don't want to do this first of all. Secondly, good. And also it's better you could like accidentally forget that you have this number over here. You see? When you do it, just chop it by 2s and 3s and put the small number on the left, then it's easier to keep track. Yeah. So, even though it's tempting to do like, 10 and 10. So just do 2 and 49. 2. All right, cool. I'm glad we have this example. And that is not a 2 right there. So that we have 2 and 7 and 7. All right. Group. Boom. 7 root 2. Check it. Boom. All right. Number 5. The 2 can't go into it because it's odd. But if you add the digits together, if you add the digits and it's divisible by 3, then 3 can go into it. You could do 5. Okay. Okay. Mhm. I'll do 5 and 3. Okay. Doesn't matter. Wait, the two fives are twins. Mm. Yep. Boom. So that was a graphic kill. And then 5 root 3. As a splatter on the wall. Poor brother. Okay, so um 256 is not harder. Oh, and don't forget, I've showed you this before, but today is the day it's going to stick. Or maybe you do this already, I don't know. But don't forget, if it's even, so it's divisible by what? You just said it. It's even, so what is it divisible by? 2, and you can do the division the short way. So 2 goes into... Okay, cool. You're the only student that I have that has actually like processed that and used that. Yeah, like I learned that. My brother showed me one time, like in 4th grade. I'm like, this is amazing. I'm like, yeah. I'm like, and I'm not going to even tell this to anybody. I'm keeping this for myself, and it's working out pretty well, apparently. Okay, so then 2 goes, so yeah, 2 goes into itself once. It really is. 2 goes into 5 2 times, remainder 1 and 8. 128? All right, so we got 256, and we got 2, 128, we got 2 and 64, we got, what? No, 8 and 8. Take it by 2. Take it, no, it's tidier to do it that way. You could do 8 and 8. 2 and 32, even though it's tempting to do 8 and 8. Then do 2, go ahead. 2 and 16. Keep going. Keep going. We got a lot of twins delivered to this truck. Oh, do we really have a loaner? Wait, we have boom, boom, no loaners. So kill, 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 and kill. Okay? Okay, what comes out of the root? All right, so you're going to go 2 times 2 times 2 times 2. What's inside the root? No. Okay, let me ask you this question. What if I had done this? What if this was like a possibility? So leftover was a 5, like a loaner. Then what will be inside the root? Right. And when there's nothing there, there's just ones. There's always ones. But what's the square root of 1? 1. Do you need the 1? No. So you could just think of it as like there's all twins. They all made a run for it. There's no one left in jail afterwards, right? If all these twins, how many do we have? 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. If this one's making a run for it, and this one's making a run for it, these two, that pair, that pair, that pair, and that pair, there's no one left in the prison. They all ran for it. So it's just 2 times 2 times 2 times 2. And what's 2 times 2 times 2 times 2? All right, now let's check it. Let's see if we did it right. No, there you go. 16 times 16, it's 256. Yeah, so 16 times 16 is 256. Do you know how to do this long multiplication style? Do you know how to do this? How do you do this? Mm-hmm. Okay. Wait. What we gotta do this part over here. What's the rest of it? So what do I get? What do I get? Wait, what goes right here? 9. You said put a 0? Okay. Wait, where am I? Wait, you just said 1 times 6 is 16. Oh, I see. You went like that. Okay, it is 16. So then you have 6. What's right here? What's right here? Boom. So make sure you check them. If you get, like, we'll finish the test first, but then you can check them afterwards. I would check them all. It's all checkable. Okay, you have. I'm confused because I saw fractions. Where did they go? It's a different lesson. Oh, it's like, that's weird. Why is this one harder? Oh, they gave you. Okay, so just real quick, if you're like on page. Oh, I know why. Because he's giving you perfect roots. Okay, so like look at. Really? Are you sure? But that's not this assignment though. Oh, yeah. So wait, but look at like number 13. So page 518. 518. Okay, so the way this works. So 518 number 13 is that actually isn't the one I wanted to do. That's funny. Let's do 519 number 13, which is a similar problem. 519. Because I don't know if the answers are available for the other one. Yeah, so 519 number 13, which is plus or minus, and you'll just leave that in your answer, plus or minus the square root of 121 over 25. And this, I'm going to show you the absolute best way of doing this problem is whenever you have a fraction inside of the root, separate the fraction. So this is the exact same thing as the square root of 121 over the square root of 25. So what was originally there is the same as that. So do two mini fractions instead of one big fraction. Okay? All right, so do you know what the square root of 25 is? 5. And then you're done. So it's plus or minus 11 over 5. 29 seems interesting. So 29, that's on still page 519. Yeah, plus or minus. Wait, before we do that. Wait. I wasn't sure if you'd get this type of problem, but it looks like you are. So before you do your mini fractions, you want to see if you can reduce your fraction first. All right, so plus or minus the square root, and like off to the side over here, let's think about like 33 over 132. Well, what's 3 plus 3? Like if I add those two numbers right there, what's 3? Okay, again, can 3 go into that? Okay, and what's 3 plus 2 plus 1? So can 3 go into that? That means top and bottom are both divisible by what? Yeah, so I can reduce this fraction. Okay. Makes life easier. So if you could, the first one that we did, we couldn't reduce 121 over 25, and they were both perfect roots. But here, it's easier, way easier to reduce if you reduce. All right, so when you reduce, so when you divide 33 by 3, what do you get? 11. And when you divide right, so we got 11 over 44. Now we put that back on our root. 11 over 44. You now split it to your mini roots. And now you're not allowed in math, it's like you're breaking like a math law, if you have a root in the denominator of your fraction. So when you do root 11 over what? Just the number 44? Root 44? You broke a math, like, not broke a math rule, but like it's like bad math grammar. You can't like leave it like that. But before we even do that, let's simplify root 44 with the rules that we know already about the prison escape. Okay, because we can handle that. So what do we have? You can do better than that. Okay. 2 and 11. Group 2 root 11. Okay, so now let's rewrite it. We got plus or minus the square root of 11 over 2 root 11. You with me? Okay, so now what you have to do, and this is the part that if you don't review, you're going to forget this tomorrow, is you have to what's called rationalize the denominator. Because you're not allowed to have the root downstairs in your final answer ever. If you have a root, it's like you're going to miss points. So you need to rationalize denominator. And all you do is you just multiply top and bottom by that root denominator. It just so happens to be the same as the top, but usually it isn't. So you're going to go, your top and bottom, because what is root 11 over root 11? Because what is all of this business? Like, what does that work out to? Well, that's the ugliest curly brace ever. What is? No. What is root 11 over root 11? 1. So you're multiplying this number by 1. So are you changing the value of the first number? No. So, but by doing that, a couple of cool things happen. What's always going to happen on the bottom is you've gotten rid of your root. So it's time to discuss the happy face rule. So I'm sure this is in your book somewhere. Yeah. So the happy face rule goes like this. I'll just teach you by pattern. So let's talk about what root 3 times root 3 is. Well, root 3 times root 3 is root what? But what is the square root of 9? Okay, well, let's talk about root, let's see, 5 times root 5 is the square root of what? But what is the square root of 25? Wait, we could do more. What is root 7 times root 7? Just the number 49? But what is the square root of 49? All right. Let's do 100. So root 100 times root 100 is what? Well, let's do it over here. Lucky guess. 10,000. And what is the square root of 10,000? So it's time for the happy face rule. What is root happy face times root happy face? No way. You telling me that root 100 times root 100 is root 100? Wait, what is root happy face times root happy face? Wait a minute. What is, okay, look at root 3 times root 3. But let's look all the way at the answer here. Isn't it the same as just one of these without the root? Right? And look over here. Do I actually ever have to go to 25? No, I can just get one of them and take the root off. Right? So what is root happy face times root happy face? Just happy face. I mean, I could tell you the heart rule, but it's just not as cool as the happy face rule. So what is root heart times root heart? Just heart, right? So like root 11 times root 11 is what? 11. So you're going to do this little trick every time you rationalize your denominator. So right here, what is root 11 times root 11? Yeah, so you're going to have 2 times 11, and that 11 came about because of the happy face rule. All right. And then over here, it's just coincidentally you have the same thing on top, but that usually doesn't happen. So what is root 11 times root 11? 11. And what can you do from here? You could cross equal, yeah. So you could either do 11 over 2 times 11, which is what? What does that become? Wrong. Rookie move. Rookie move. No. Well, now you're just guessing. Because what is 11 over 11? All right. So what you're doing is you're dividing. When you do this little wiping out action, you're really doing divided by 11 divided by 11. So you still got a 1 on top. So when you do little wipeouts, you have baby 1s on top. By the way, there's a teacher at Pally who calls that like freshman mistake, and like that's like that is the number one. Well, actually, not the number one, but like top 3 algebra mistakes. People do that all the time because you think like, oh, there's just a 2 left behind, but no, that 2's left. That 2's downstairs, and there's little baby 1s on top, so it's going to be 1 over 2. You with me? The other way of doing it is, I like that you saw that you could wipe it out though. The other way of doing it would be just to write 11 over 2 times 11. What's 2 times 11? And then reduce 11 over 22. What's 11 over 22 reduced? 1 over 2. So that's also, you could do it that way. Okay? So it's tricky because of the whole like rationalizing action. So if you do, and some of them you don't have to rationalize. Let's see. 21. Let's try 21. This is still page 519. All right, so 21 is negative. Wait, what was the one I just did? 29. Oh, 29. I got really excited about my answer, but it's supposed to have a plus or minus on the front. You see? Plus or minus. So it's still there. So it's going to be plus or minus 1/2. And plus or minus 1/2. All right, so let's talk about 21, and we'll talk about the decimally thing. And then when you do your homework, make sure you check your answers for the back of the book. And text me if you get stuck, and I can like text you solved problems. And review tomorrow. Okay, so 21 is root the square root of 28 over 63. So step 1, see if you can reduce your fraction. Reduce fraction, because it just makes things a little easier, if possible. So, wait, what does go into these guys? We got 28 is 4 and 2. Wait, 8, 9, 10. Wait, look, can 3 go into 28? No. And if you chop 28 down, it's 2 and 14 and 2 and 7. Can 2 or 7? Oh, can 2 or 7 go into 63? Okay, so we got 28 over 63 divided by 7 divided by 7. All right, then what do you end up with? On top is, wait, what's 28 divided by 7? Wait, 4. And then on the bottom you get 9, which are perfect roots. So this ended up being not too bad. So then you end up with, you don't have to rationalize. Nice. Root. So this is, you can split your fraction. Don't forget to split. And then what do you end up on top? And then what do you get on the bottom? Okay, let's talk about the decimal one. So it's negative 2/3 for that answer. Okay, all right, so what's the, show me a decimal one. You mean like number 33? All right. Oh, I don't know that trick, but I do know. Okay, we can explore that in a sec. So I do know about like the spitting section. His trick might be really better than mine, but let's see. So you have a decimal here, you have a decimal here, and then you got that place value. Wait, hold on. So you got a decimal. You got this place value, 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 this place value. Okay, so the decimal is your and. It's the word and. Right? So if you have like, I'll explain that in a sec. And then over here is the ones place. Over here is the tens place. So like, like this is $1.23. You'd use a $1 bill. Okay, so it's a ones place, tens place, hundreds place, and thousands place. And then over here, this is the spitting section. Spitting section. And it doesn't start with the ones, it starts with the tens, but it's the tenth place. So that's the 10th place. This is the 100th place. 100th place. This is the, what place is this? 1000th place. And that's the 10,000th place. Okay, so here 1.3 is 1. 1.3 is I should totally be like a classroom teacher. I'll just spit on a kid. 1 and watch 1.3. 1 and there's the and 1 and 3 tenths. See, because it's like it's 1 and 3 tenths because you're in the tenths place. Spitting section. See, so ones place and 3 tenths. So 1 and 3 tenths is 1 and 3 tenths. Like that. 1 and 3 tenths. But then you have to, do you remember how to turn this into an improper fraction? How do you do that? So it's 13 over. Okay, and then if you're rooting this, now if you take, if the job, like I just made this up, but like, let's say that goal was to do that. So then it'd be, and then you had to do the both, and then that would be, you got to rationalize the denominator because we are rationalizers in this household, young man. And 10, and then over here, and then what do you get on the bottom? Happy face rule. 10, and then on the top, what do you get? In the root still, and it can't take it out, I don't think, because 130, yeah, it's in there for life. Because look, it's not happening. So that's your answer. So if you're looking at like number 33, which is not what I just did, if you do number 33 is root 0.4, 0.04. Okay, so that's, there's no one and business. It's just for what's. Well, how do you read? Yeah, it's 4 hundredths. So it's 4 hundredths. You see? 4 over 100. Now if we're taking the root of that, now I can skip a step and just be like, because I know I'm going to do that anyway. It's like that. So then what is the square root of? Why? Oh yeah. But I saw that they're perfect roots. Yeah. So then it would be square root of 4 is what? Square root of 100 is what? If you didn't, and then you're done. If you didn't see that and you did it the way you suggested, so if you're like, all right, I'm going to reduce that fraction, right? You're like, all right, I got root 4 over 100, and Steve's like, always reduce your fraction, and it's going to be like that, and then split your fraction, then factor tree, and you're going to get, are you with me? Okay, then you're going to get root 2 over, and then it's going to be, you didn't do the jail right, 5 root 2, right? And now we're going to rationalize. So times top and bottom by what? Because of this guy, right? Yeah, so root 2, what do you get on top? 2, look at you, happy face rule guy. Oh, what is it? What is it on top? Just the number 2, right? Root happy face times root happy face is happy face. Otherwise, you got to do the in-between step and say, oh, that's root 4. Oh, what's the square root of 4? The square root of 4 is 2. And then over here, you can happy face rule this as well. All right, what do we got? What do we got? We got 2 on top. On the bottom, you're going to end up with 5 times what? Times 2. What happens? Well, we can do this, but are we rookies? What's the answer? 1 over 5. So baby ones, nice. 1 over 5. And that's how you do it. Hold on a sec. Shoot, I'm like majorly behind schedule. Okay, I gotta run. So watch, what I'm gonna do. I'm gonna go